Essentially, we are offering real-time data. So we're like a Web3 platform that essentially makes it easy to really efficiently read whatever is happening on chain. So if you want to have insights into like network transactions or who's in what wallet, what kind of balance, just basically anytime you want to build an app that relies on information on chain, the really most efficient way of doing that is by indexing it. And that's what subgraphs are. And then Mirror basically takes that to the next level by basically putting that on-chain data into a database. So really what you can think of Goldsky as is it's like this pipeline where it makes it really easy to take anything happening on chain and either analyze that or to create an application that's based on that. So really we just want to make it as as smooth as possible to interact with on-chain data, whether you want to, look into what's happening or build an app on top of that. So and now we got Javi coming up from our Gold Scout team, a solutions engineer, and essentially he's going to give you guys a quick little demo on what exactly subgraphs and Mirror can do. And once you guys see that, we'll send over some documentation so you can take a look after and hopefully build out some cool stuff on mainnet. We're super excited to see, what the Morph ecosystem has in store. And, no doubt it's going to be really awesome because everyone in this community is super excited, which is pretty cool. I mean, everyone always comes together every week and, it's just awesome to see. So Javi, I'll pass it along to you and let's get started.
All right, cool. Can you guys hear me well?
Yeah, you're good.
Okay, sweet. Yeah, full house in here. Actually, that's pretty exciting. Yeah, one thing I'm having some issues sharing my screen. Maybe because if you can, maybe give me some extra permissions to do that, that'd be pretty useful.
Right now, it should be able to pop up for you.
Okay, let's see. Yeah, still not there though. Let's see. Am I supposed to look somewhere? All right, I think it works now. Yeah, okay, cool. Let's go ahead. Let me just do the screen. That call. But at the same time, for those of you who were on that call, also want to make it interesting, right? So what I'm going to be doing is we're going to be covering a very similar agenda to the previous call. But here I'm going to be digging a lot more in our second protocol, Mirror, because unlike with testnet, now with mainnet, we do have the ability to stream actually mainnet data into your database using Mirror. So that's going to be a lot more exciting than subgraphs, in my opinion. But before we do that, we're going to be covering the basics of why indexing is important. Then talking about the subgraphs, I'll just walk you through the basics of it, and then if you guys have any questions along the way, we can just like answer those. Both for normal, standard process of developing subgraphs using GraphNode, or if you want to use Goldsky Instant Subgraph, which is something very cool, as you will see later, because it basically allows you to deploy subgraphs without having to do much coding. Basically, we're going to be doing the coding for you, and then at the end, we're going to be getting into how to mirror data into your own database, specifically Morph mainnet data. By the way, I don't really have visibility. I only have one screen. So Andrew, if you see any questions on the chat, just let me know. But yeah, like feel free to ask any questions along the way and interrupt me. Otherwise, at the end, we'll leave some space for Q&A. All right, cool. So why indexing is important? Kind of if you think about blockchains, it's just like a continuously growing list of records, block by block, one after the other in a sequential way. And it's pretty great to, in terms of storing data in a way that is permissionless and trustless, right? Now, the funny thing about it is that putting the data up in there is relatively easy. Reading the data from it is actually quite complex. And so if you think about the data that is in a blockchain, there's a ton of information. Depending on the use case, you may be interested in just blocks, or you can go very granular in looking to all the events emitted by contracts, or the traces from different contract calls that have been made on that specific transaction, etc. getting that data is actually very difficult. And historically, how we have been doing this is, basically doing RPC calls on public methods on the contracts deployed on the network. And although you cannot really see much here, basically, this is just like a little script here that we did for displaying 20 NFTs, a collection of 20 NFTs on a normal website. And so that took 41 network requests, and that took around 20 seconds, right? Just to display 20 NFTs. So you see this original method of getting the data in a one-off manner, where you're basically, just calling the contracts that you need every time you load the page, is actually super inefficient, and the user experience is just like terrible. At the same time, it puts a lot of load on the nodes, because these nodes also need to serve those requests, right? So the way of just making RPC calls towards the blockchain directly, it's not really scalable. So this is why indexing came kind of to the rescue as the most natural solution to fix the issue, right? And so what indexing is basically you create a parallel database to the chain that pretty much it contains the same information as the chain itself, but it contains it in a way that is a structure that is a lot more easier to work with and read from. And so you can think about these indexers to be basically like, blockchain scrapers that are continuously getting notifications from the chain and then adding that into its own database, so that you can basically, this way you can scale the data layer in a much more efficient way without bothering the nodes on the network. And this is what takes us to subgraphs, right? Probably I'm pretty sure most of you, or if not all of you, are familiar with subgraphs in some way. Subgraphs have been the de facto indexing technology since the beginning when it comes to indexing. And the same, how they work is that, as we'll see in a second, you will define what you want to be scraping the data from, or what data you're interested into indexing. Then the subgraph will go ahead and fetch that data from the database and store it in a Postgres SQL database. And then it will also immediately expose an API endpoint via GraphQL that you can use to query that information. So it's a very, very easy and nice way to work the information that you're interested into from the blockchain. And so subgraphs were originally developed by The Graph, but they open sourced the technology. So what we did here at GoldSky is just we took this technology, so we are fully compatible, but we also have improved it in several ways when it comes to the query performance, reliability, as well as we've added features on top to make the development experience a lot easier and a lot more convenient. Like, for example, these instant subgraphs that we're going to be talking in a second, where you can deploy subgraphs without any code. You can also have webhooks. You can also do versioning on the using tags, etc. Cool. So, all right. So let me show you what we're going to be doing is, as I said before, we're going to be talking about subgraphs, but not so much in detail as in the previous workshop. I think that workshop is recorded, so you can definitely go ahead and check it out if you want to dive deeper into it. But I'm just going to be talking about the basics of it, right? So when you deploy and you create your own subgraphs to index that data that you're interested into for your application, there are two ways to go around it. One will be to go through the standard graph node method, where you're going to define basically a structure of files, and then you have to compile those files and you have to deploy them onto the indexer, right? So that takes a little bit more development, but it's good to know that style of working, because you will be able to understand other public subgraphs, and you will be able to fork them, and you will be able to create your own version. So we're going to be looking into that, and at the same time, we're also going to be looking into how to deploy subgraphs without any code, just like having GoldSky creating the code for you. And so for that example, I created this repo over here. And let's see. By the way, my connection is at a hotel in Mexico, so it might not be best. Hopefully the call is just working fine. Let's just see while this loads. Okay. All right, here we are. Cool. All right, so in this repo over here, which by the way, I shared with you, if you can share, the actual deck with the team, it would be great, so they can also access it. But basically here, you're gonna have, two types of subgraphs. We're gonna be looking into that. Main will be mainnet, testnet will be testnet, which is the one we went through the other day. Let's look into how you will be deploying subgraphs via the normal method, let's call it like that. So basically here, if you look at the subgraph structure, what we're gonna be doing here is that we're gonna be indexing this beachhead token in Morph mainnet, right? So, which is right here. So let's say if you want to, in the case of the subgraphs, we're gonna be indexing the transfer events emitted by this token, and then we're gonna be creating a balance, which we're gonna be able to query via that endpoint that the subgraph provides. And so to do that, you need to define a couple of things, right? You're gonna have to define this subgraph YAML file over here. So let's look into that. The subgraph YAML file essentially tells the subgraph what to look for, right? So in that case here, we're gonna be needing a couple of pieces of data which are quite important. So that's gonna be while this thing loads, that's going to be actually maybe just gonna do this here. It's gonna be just faster. I think I have it here. Cool. All right, cool. So what we're gonna be needed from for the subgraph is we will want to explicitly put the network slug, which is basically a way for the indexer to know among all the networks that is indexing what to look for. So you want to be using Morph for mainnet, and if you want to do testnet, you will want to do Morph testnet here. In this case, we're just doing Morph, right? Then you need to specify the address of the token. You will want to specify a start block. You can define here the actual block creation or any start block that you're interested into. And then ultimately you will want to define mappings. So the mappings is basically the way by which we are able to define our logic, right? So in this case, we're saying, hey, there's going to be an event transfer called transfer index event. So this is the definition of the event we're going to be targeting. This event is actually based on the ABI. So it's very important that if you want to index any contract on the network, you will first need to add the ABI so that the subgraph knows how to read this data. So once you provide the ABI, which I have it here, over here, I can define what events I'm interested into, and then I can define the handler. So the handler will be the actual function in JavaScript that is going to be defining the logic for what to do with that data. So this is going to be the subgraph YAML file. Cool. Then another important thing you want to define is the GraphQL. So the GraphQL, think about this as basically the data layer. Here you define these entities. And so ultimately, when you deploy a subgraph, you're going to be querying these entities, right? So whenever an event happens based on your contract or on your mapping logic, you will end up saving entities. So in this case, we have a token entity, we have an account entity, and a tokens balance entity, right? And then ultimately, probably the most important part here is the actual mappings. We don't really need to get into the much detail of it, but basically here in my YAML file, I said, subgraph, whenever you detect this transfer event from this contract, call up this function, which is handle transfer. And then here, what we're going to be doing, essentially, just like looking at the code pretty quick, is that based on the data, on the params of that event, we're going to be creating, basically we're going to be creating those entities, right? So we're going to be creating a token balance entity, and we're going to save it. And we're going to be also creating some accounts balance, et cetera. Let me just go back here. We're going to be creating these entities right here again. Account, token, and token balance. All of that based on the information for that event, right? So that's really what this mapping is doing. So I'll leave it up to you to look into the code if you want to, but the way it works is that based on the from, to, an amount, it's just going to subtract or add a specific amount of that token into each token balance account. So that's what it is. Okay, cool. So this is pretty much it. Now, if you were to go ahead and you want to deploy this SAP graph onto GoldSky, the first thing you need to do, and I'm going to make this bigger, by the way, is you will need to define, or you need to download the GoldSky CLI, of course. I already have this in the define over here. And then another thing you want to do is when you download the GoldSky CLI, you will also want to log into the specific project you belong to. So for those of you who don't have an account yet, you can go here. You can go to goldsky.com, and then you can create an account by basically going to the dashboard. Cool. Now, I already have my own account, as you can imagine, which is right here. So this is my own workspace, and I have created an API key, and I have, basically connected my CLI to my project. So what I'm going to be doing now is I have everything is already set up here because I already created it. But usually what you will need to do is you will need to create this folder over here, which is, let me see here, which is the build. So these build files is ultimately what will be sent to the indexer. If you were like starting from scratch, you will need to do graph code gem. This will generate the code based on your here stuff graph code gem. This will generate the code based on the information you have added to these files, and then ultimately you will want to do graph build, and then the graph build will create that build folder for you. I already have done this before, so all I need to do now is GoldSky SAP graph deploy, and then specify a name for this. So in this case, for instance, let's just call it BGB morph, and one for the version of it. Cool. So now what we're going to be doing here, the GoldSky Sapphire command is taking the deployment folder and is actually, deploying this onto my project. So now, as you see here, I've been given this API endpoint. Cool. Let me just make it a bit bigger. Cool. And then here, basically, what I like to do is this is basically the API endpoint that is talking to the deploy SAP graph, right? The one that we just deployed. And you can also see this here. If I reload this page over here, you're going to see that, my BGB morph SAP graph is already being deployed. So via this GraphQL endpoint, I can actually get that information. So one thing that is very convenient, in my opinion, is that here on the left side, you have this way to create your query objects. So here, for example, you can just build a query object for token balances. I can say, give me the first 10, well, give me the amount, give me a token, give me the ID of the token. So, and then you can query that information from here, which is right here. And then, of course, like, as you can imagine, we're just doing this through this interface. In reality, you will be connecting your applications through this endpoint and making the queries from there, and then fetching that info, working on it, and then displaying the info to the end user. That's what many applications do today, like Uniswap or whatever you can think about. So this is one way to go around it, and this is very cool. I definitely recommend you guys to keep an eye on this one. Really understand the code over here, but everything really works the same way. If you were to copy another SAP graph, it's all about those three main files, and it's all about building the build folder to deploy onto the indexer, right? So that's pretty much it. That will be standard development process for SAP graph. Now, if you were to deploy SAP graphs using the other method, which is called instant SAP graphs, is a very cool feature that we have developed here at GoldSky, and it simplifies things quite a bit, right? So let me go back to that into the folder. Let me just close this. So now what's the difference here with this other method of deploying SAP graph? As you can see here, the actual code is a lot more lightweight, right? It all consists of the ABI. We always need the ABI, which is the exact same one as the previous one. And now we just need a config file. This is the simplest it gets, right? Basically, you define a config file where you say where the ABI for your contract is, what's the address of your contact, which is basically this is the exact same token from before, and then you define the start block, right? And that's pretty much it. Now, only with this information, we can deploy a SAP graph. So that will be using GoldSky, SAP graph deploy. And then we're gonna call these, let's just say, for example, token or another token, just say one, and then from ABI and this config JSON file. Let me just do one thing here. I need to go into this folder. There we are. Okay, cool. Goldsky, Subgraph deploy. LK token, morph one, and then from ABI config JSON file. So from the ABI takes this config JSON file. And yeah, that's pretty much it. Now, as you can see here, we generate the subgraph for you. So, you know, all the skeleton that we were looking at before, all those YAML files, you know, GraphQL files, TS files, all of that we create for you based on the configuration file here. And then again, now we have another endpoint here, which is pointing to another subgraph that we have deployed. If we just reload here, you'll see the other subgraph. And then we can just query the information from here. Now, in case you might be wondering, why does it have these entities in there? If you don't really modify the standalone or the simpler configuration file that I just showed you, we're just gonna be creating a subgraph that has as many which has as many entities as events params there is in the event that you're looking for. So in this case, we're looking at transfers, main burns. These are all contract events that are defined in the ABI. You can actually change this behavior using enrichments. So that's something that is added into the docs. So you can also extend this logic to make it more, tied or more flexible according to your specific needs. Still, we will be generating the code for you. All right, cool. So that's pretty much it. In the previous workshop, we were looking into subgraph in a lot more detail. In that video, I explained, in more detail, basically, some other many cool things that you see with Goldsky when you deploy subgraphs into it. We're not going to be talking about them in detail now, but basically, if you zoom into a subgraph detail page, you're going to have a lot of very interesting information on it. You're going to see the entities being stored. You're going to see if anyone is fetching that information. You will see API request information about it. How long the subgraph takes to store the data, as well as create webhooks and have some blogs to see if anything's going wrong or whatever. All right, so that covers kind of the first part of the demo. I don't really have any visibility into Discord, so hopefully there are no questions at the moment before I go into Miro. Okay, I'm assuming we're good there. All right, cool. Cool. Right. Now the second part of the workshop is what kind of gets me more excited about, because subgraphs, as I mentioned before, they've been around for a while, and that was, it's been open sourced, whatever. The thing with subgraphs is that, as you saw, it's pretty useful, pretty handy. And I actually love them as well. Like, if you can very easily create great subgraphs that will give you a bunch of super specific information. And, many people today do it. Like, any app you can think of, like Uniswap, for example, they use subgraphs, right? So it's a very well developed technology. The problem with it, though, is that it has its own shortcomings, right? And if you think about what are these shortcomings, the main one, the main issue, let's say, is that the way that you ingest that data is via that GraphQL endpoint, right? And so it's not very convenient to have the information be queried via that GraphQL endpoint for every use case. It's not that scalable, right? And so if you think about use cases that are a bit more complex, right? If you want to maybe merge off-chain with cross-chain data, right? That's something that subgraphs can do. Subgraphs can only communicate with on-chain data. If you want to do more advanced functionality in terms of, for example, fuzzy search, right? Where you type just a letter or a character, and then immediately will show you all the similar results. Like, that involves a lot of heavy lifting on the data side. That's something you can do with a GraphQL endpoint. Same goes with proper analytics. Same goes for many of the more advanced data use cases, right? Like subgraphs, exposing that data endpoint via the GraphQL endpoint. it's just like not that scalable if you were looking into more advanced use cases. So this is why we developed Mirror, right, to pretty much overcome the shortcomings of subgraphs, in the sense that here you basically can create pipelines that allow you to basically stream that information all the way into your database. So now you own the data, right? With Mirror, you own the data. What that means is that there is no restrictions on, for example, of the number of queries that you can make on the data, because now that you own the data, you can collocate that data into your own data warehouse at the more convenient place. Now, at the same time, you can also mix off-chain with on-chain data, right? Because the data from on-chain, you can be streaming that into a table that contains user information or any other website activity that you may have. At the same time, you can also be reading data that is not only from a chain. You can also be reading data that comes from your own database. Maybe you have something like Kafka in-house or something like Postgres. We can also read from there and then transform the data on the fly and send it over, more importantly, to the technology that best suits that specific use case they're looking for, right? If your use case is about, for example, data analytics, then you might as well want to transfer the data into something like ClickHouse. If you want for more relational databases, then you can do that into Postgres. So basically, it's just a way for you to own the data and do with it whatever you like. So you don't really have the restrictions of having to rely on your indexer and the GraphQL endpoint that it shows to fetch your information. Now you are the owner of your data, essentially. Okay, cool. So this is the theory about Mirror. We're going to be diving into that now in a second for a small demo. What's important about Mirror is that these pipelines consists of three main components. That would be, on the left side, we want to define the source of our data. It can be any source. In the middle, we might or not want to transform the data on the fly. And there are many use cases for it. You may want to filter for a specific contract address. You may want to change the shape of the data on the fly, whatever. And then ultimately you want to sync the data into whatever technology you want, right? So these three components: source, transforms, and syncs. All right, cool. So in this case here, let me show you an example of how we can deploy these pipelines, right? So if you go to pipelines here, now you hit new pipeline, you're presented with this cool GUI where you can deploy and define the components of the pipeline. And by the way, I will show you, now we're going to be going through the GUI kind of interface, but you can also definitely do this as well on the CLI in case you are more of a CLI type of person. But yeah, as I said before, you want to define a data source, right? So my data source is going to be, I'm going to choose for the Morph network, and then I'm going to say, we have these data sets available for pretty much every EVM compatible chain. You can get Roblox, Rologs, and traces. And then at the same time, you can also get things like what we call curated data sets, which is data sets on top of this raw data. In this case, we can do ERC20 transfers, for example. So because we were doing an example of that before for subgraphs, let's do the same for this one here. One more thing as well, which I want to call out, is that you can also use as the source of your data subgraphs that you have deployed previously on your project. So these are the two that we just deployed before. This is a great way, of course, for you to own the data of the subgraph and pretty much overcome the limitations that I just explained before with the GraphQL endpoint. So that could be another option. For this example, let's just go ahead and choose ERC20 transfers. I'm going to call this differently. I'm just going to call this, ERC20 source, for example. And then here, we can look at the schema, right? So you can see what data schema is going to be coming into our database. It's going to have these fields on it, right? And we can also get to see, some sample data. So you can get to see like actual real data, in case you want to, double check things on the network or make sure that this is the data you want to get into your database. So this looks good to me. I'm just going to choose this source. Now, next, we can define either to sync the data directly into my database, or I can maybe transform the data on the fly, right? And so for that, we have two options here. You can do a custom SQL transformations, right? So you will be working on, doing any sort of SQL transformation on the pipeline as it goes, or you can also do HTTP handlers, right? So this is very interesting. Essentially here, instead of doing the transformations on SQL, you will be creating a Lambda or some sort of third-party web service that will accept incoming requests from the pipeline, and then you will be doing the transformation separately, and then devolving those or returning those process data into the pipeline again. I have one little example here, which let me just see here. Transformed. Okay. I want to show one quick example here. Over here in this repo. So here you have a pretty simple example where it's just basically some sort of Lambda in Node.js, and all we do is just like get the data and transform it and return it back to the pipeline. This is taking a while actually. So okay, there we are. Cool. So look at this. So this is very simple. This is just an endpoint here. Defines an app. Here is my transform endpoint, and it gets the data from the pipeline, creates a new response for the data. So it transforms the data, it enriches. In this case, it will enrich the token symbol and token decimals, and it will return that information back to the pipeline. So this is just another example that you can look into if you want to work with HTTP transforms. In my example here, I'm going to take it easy, and I'm just going to create a very simple custom SQL transformation here. So if I just go over here, if we look at the source of the data, is this one, right? This will be the shape. So let's say that I'm just interested in getting the ID, getting the address of the token, sender, recipient. Let's just get recipient, and then amount, and the transaction hash, right? And so in my transform, I'm just like taking some of the information that's getting from the pipeline, just to show you one quick example. So this is all we're going to be doing here in this little transform. Cool. And then ultimately, we want to define a destination for my pipeline. So in order to sync data into your technology of choice, you first need to go into your project and you need to create what we call secrets. So a secret is just a way for GoldSky to securely encapsulate the credentials to talk to your database. So in my case here, I have many things already being created to talk to different technologies. So I have a few for ClickHouse, and one for, I think this is actually for single store, another one for SQL. So yeah, but you can also define new ones here on this UI if you want to. In my case here, I'm just going to be syncing the data into my demo project. So I'm just going to choose this one. Then we can define the table. So I'm just going to say that the table that will be created will be ERC20 morph. So it will be the table created in ClickHouse. And you can even go and do more advanced configuration on the pipe on this syncing. So you can define batch sizes, flash intervals, etc., in case you want to tweak how quick the pipeline writes the data into your database. In this case, we're just going to leave it as it is. Okay, cool. Last thing here, I'm just going to call this morph mainnet pipe. This is going to be the name of my pipeline. I'm going to save it. Cool. And then I'm going to hit deploy. The last thing, when you hit deploy, you will want to define a resource size. The resource size is basically the amount of compute that you want to add into the pipeline, right? So if you have very large amount of data to work with, you can define large pipeline resources. If you're just doing a normal, one-on-one kind of chain thing, when that's small, you should be fine to go. Okay, let's just hit deploy. And now here the pipeline will be getting deployed essentially, right? So in the background here, what we're doing is we are essentially setting up the appropriate resources to get everything working. So that will be reading the data from the morph mainnet data sets that we have in-house, then writing or creating a table on the sync side on my in this case over here. So we'll see a table being created here soon. And then ultimately, the data will start flowing in there, right? One thing you could do here, which I really like to do, you are gonna have some logs in here. So we're gonna start seeing the logs in here as soon as this is live. One thing I like to do is I come here, And then if you do Gold Sky pipeline monitor, and then the name of the pipeline, this is just going to give you very good insights into the actual runtime of the pipeline. So here, as the records are received and written, we're going to be seeing here how this is going to get updated. It gets updated every 10 seconds. So that's one thing. And one thing which I wanted to call out as well, very important, is pipelines are formally defined using these YAML files, right? So what you see here is that this UI that we went through by drag and dropping cards and whatever, in the end created this YAML file. So this YAML file is how you would usually be working on with, for more advanced use cases, you may just want to copy these files and work directly with them, because here you can just directly work on the transforms. It's convenient. It's very easy to work with. You can update it. You can even version control it into your GitHub repository, etc. And then, as I mentioned before, we went through that flow over here, but the reality is that we can also do the same here. If we do Gold Sky, and then we do sync data with Mirror, you see here the process is the same, right? So test pipeline, and then we're going to be doing the exact same thing that we were doing before, right? Defining the source, we define the chain, etc., etc. So it's just like, if you prefer to go through CLI, it's also possible to go through CLI. That's no problem. Okay, cool. Let's look into how this is going. Now you can see that the pipeline is getting some records and writing the records. So this is already working. If we go here and fetch the logs, we're going to start seeing how the pipeline is reading the data. Is already backfilling that information, which is pretty good. If I go into my ClickHouse instance, you will see that now ERC morph is being created. And now here, I got the data over here. So it's pretty good. It is going to be writing a bunch of data in a very, very fast way. A Nest pipeline, if your database can handle it, it can write at the speed of 200,000 records per second. And that's only a Nest. If you increase it to XXL, you're going to get super, super, super high through output. So that's pretty much it. Now we own the data. Now we can do whatever we like with it. We can, for example, we can create an API on top of it. In my case here, I wanted to show you a cool thing. I have this database connected to a thing that we call Dash, which is a way for for you to display information or get insights about the database. It's like an interface to ClickHouse, I would say. So here, if I just do this, and I choose demo, I'm just gonna rescan these files. It's just a demo environment, so I need to do this manually. But if I go to databases, I go to here. Now we can see my databases here. So I think it was this one. Cool. So now I can get the data in my analytics database, and then I can do cool things here, like, I don't know, whatever is, filter by address, for example, and then display some nice metrics on top of it, or whatever is interesting for us. So, now that I own the data, possibilities are endless, right? That's the huge difference with SAP graphs, where you were limited to this query endpoint, basically, and you do not have the opportunity to work with the data and mix it with other sources of data. So I think that's what's really cool about Mirror. And as I mentioned before, you can deploy many types of data sets for Morph. You can deploy raw logs, raw traces and transactions, as well as ERC20, 1155 and 721 transfers, as well as any SAP graphs that you have deployed onto your projects. Cool. So yeah, that's pretty much it. Yeah, that's pretty much it from my side. I don't know if there are any questions on the chat. Let me just go back to it to double check. Okay, cool. Well, maybe I'll stop sharing, by the way. Maybe that's more interesting. Cool.
Hey, Javi, quick question in the chat. Someone was asking about querying historical data. How would you suggest they go about that?
How is it, like purging, you say?
Yeah, just like querying historical data if they wanted to do that on Morph.
Yeah. So that depends on what technology of choice you go for. As I just showed, let's say if you really want to have control over the data, and you worry about low latency and doing any sort of transformation of the data, I think you might be better off using Mirror, right? If you looked at the example I just made before, the Mirror pipeline, you can define it to start earliest, which is basically from the very beginning of the chain, or latest, which is basically from the chain, right? So if you do earliest, you're gonna get a full backfill of all the data for Morph that we have. So this will be one way to do it. Then you will have the data onto your database, and then you can query it the way you like it. If you were going to do this using subgraphs, then looking back into the example I just made, basically you will define the start block to be sometime in the past, whatever that point in the past you're interested to start indexing from, and then on your GraphQL endpoint, you're just gonna have to do your queries and add filters to it based on block number, based on timestamp, whatever. So that's how you will be fetching that historical information only.
Hi, Harvey. My name is Ernest. I'm part of the DevRel team at Morph. I do have another question. So how does GoldSky handle things like frequently queried information? Like, is there some sort of like caching that's available? Is there some like caching strategy available for developers so they don't have to like make new queries if the data is, itself is unchanged?
Gotcha. Yeah, I think very good point on that one. We definitely have cache on how we index the data, right? So how we basically create your subgraph database in a way. So if there are if calls that we see over and over, we just add them to the cache and we don't bother the RPCs. We just basically get them from the cache. So indexing will be a lot faster. Now, in terms of if you query that endpoint, are you gonna get cache on that endpoint? I don't think so, but I will definitely double check this one internally because I think it's very interesting, by the way. But if you really were worried about caching, low performance, whatever, then I think that's better to mirror the data into your database, because once you own the data, you can just add whatever cache you're interested into. So yeah, I would say like here my answer will be mirror or stream the data into your database and collocate that data closer to your application, and even consider adding a cache on top of it to make it super fast. And that's what our customers do here. Maybe one thing I wanted to call out here is in terms of the economics of it, we don't really charge per query. So if you were to use subgraphs, you can query anytime that you like. We're not going to charge you more or less for the amount of queries that you make. I just want to kind of make that clear.
Awesome. One other question I have, which is more around like onboarding new developers. So is there some sort of like dashboard where developers can see sort of like sources or sort of like data sources, kind of similar to how Oracles have like these dashboards with like example price feeds that sort of gives developer an idea of what to build? So does GoldSky have something similar? Like I look at the homepage of GoldSky and I can see like there's Polymarket trades being streamed live. So is there like a dashboard where I could see example of things like that, where it could like inspire developers on what to build or what to work on?
Yeah, that's a good point. I think we are actually considering doing something like that, and very likely our most similar approach to that is the following. I would say like if you were a new developer, I will go through these steps basically. Let me just do these screens. Cool. So first, in the docs, you have we have chains, right? So here you get to see all the chains that we support. So let's just support the network. Sorry. So here you see for subgraphs all the networks that are supported, and then for mirror, you're gonna see the basically all the AVMs that are supported, as well as the type of data that you can expect from it. And then what you mentioned, for example, these Polymarket data sets as well. So here is like an explanation in simple layman terms of what this data is about. Then you have a reference here to see the data schemas for each of these data sets. So you get to see like, okay, what data am I going to be working with if I were to use, for example, an EVM chain with the rich transactions? So that would be one thing. Now, if you wanted to see like actual data, I think today the most similar approach you could do is that you can go to pipelines, see a new pipeline, and as I mentioned before, right, drag and drop here, say, hey, let's go back to it. Let's say like Morph is what I'm interested into. Let's say I'm interested in rich transactions. I can view the schema here, and this is the schema again that we were looking into the docs, and then you can actually see sample data. So this is the data that you can expect on your database, basically. This is just a sample of it. And this is the way how you can actually anticipate if you want to transform the data or do whatever on your sync. I think this is pretty much what you will be doing today to get there, right? Is that something that clears your question, or?
I didn't get the last question.
Sorry?
I didn't get the last question. The
No,
last thing you
yes.
said.
Like, is this something that, I mean, like, from your experience, is that something that will help you with what you were, asking about before?
Oh yeah. It is quite relevant. But I was talking more like let's say for example, the Polymarket one is an example, right? So the Polymarket, there's just a dashboard and there's one that says, oh, here are Polymarket data feeds. Here's like data feeds from transactions on Aave. Here's data feeds from transactions on BubbleSwap. And these feeds or these endpoints are sort of available for developers to sort of like pick and then use or come up with like project ideas they could build with those data. So that's kind of what I'm talking about. And if it's possible or if it's already available on GodSky, it's more about user onboarding than say existing technology.
Right. So that would be like deploying a small version of whatever data you're interested in to see
Exactly.
the data, right? Yeah. I think I don't know if that's an scalable way for us to do that, honestly, because that would mean like any person being a user or not will just be deploying a pipeline. And by the way, for the record, whoever who is not following here, this is what we mean, by the way. If you go to the main website, you will see Polymarket datasets being streamed on the fly as we go in real life. So I think the approach here is definitely possible, but you will just need to be deploying the data set for yourself, and that's why I meant that. Oh, let's go back. That this is pretty much the flow here. Like you will be looking at, okay, what data I'm interested in, what shape of the data can I expect, what sample data, and then if you want to deploy a quick pipeline and to see a preview of it. And we're working on previews, and I think that's what you mean, like having a preview of this data being showcased somewhere without having to be explicitly added into a database. That's something that is in the works, by the way. So yeah.
Thank you, Javi. And then finally for me, it would just be just more of a general question around like what feature or what specific aspect of GodSky do you really wish like developers knew or developers would use more? Because a lot of times with a lot of protocols, there's like really awesome ways to do certain things, but a lot of developers are not aware of it, maybe because these new methods are sort of new. So what new thing would you really wish that every developer coming to build on GoSky or we sort of learn about?
Right. Yeah, that's a great one. I would say that there's so much power in. I would say the focus will be mirror pipelines. There's so much power into this thing. Like even for myself, I keep on learning more and more, and I see customers what they implement. It is actually crazy. For example, what I showed before over here, right? This example, this is using an external transform. So here we are sending the data to an endpoint and transforming the data and sending it back to the pipeline. The possibilities that this unlocks are incredible, because what this means is that you can basically enrich the data with off-chain data. For example, you can, if you look into tokens, you can enrich the token information with the current USD value if you want by calling another API. So definitely because of the limitations that are there in subgraphs, which I mentioned before, being that GraphQL API endpoint the only door to access that data, and because Mirror just lets you on the data and it gives you all this flexibility and subsequent latency. I'd say like I would focus on Mirror and really how to exploit the best out of it, and then spend time on it because it's super powerful tool, honestly.
Super awesome. Thank you so much, Javi.
For sure, yeah. Let me just up this.
All right. What an amazing session. Thank you guys so much for displaying all of that so uniquely in our community. We absolutely love being able to get interactive in our community, show people exactly what's going on. And of course, the questions came flowing into the chat as I saw Andrew just typing away the entire session. So absolutely love the activity. We had over 1,500 people tune in on Twitter, over 65 live viewers here on Discord, being really interactive and diving in. And just wanted to say thank you both to Javi and Andrew for coming on this session. It's always a pleasure to have you on, and we know the community absolutely loves Goldsky, values your proposition so much, and just really, really, really loves your personalities that you guys bring to the table. So thank you so much for showing up here today.
Cool.
Of
Thank you,
course,
guys.
and thanks for having us on.
Yeah, thanks a lot. And I would say, keep on grinding, test stuff, and definitely let us know if you run into any issues and need any help. We're happy to help all the time.
Absolutely. Thank you so much. So as we go ahead and close out the session today, once again, want to thank the Goldsky team for coming on. We will definitely be having them on very, very soon. Want to let everybody know that this Friday, the Fun AF Fridays will be canceled. We will be doing something next week. Hopefully something really, really fun that you guys will enjoy. But for this week, we will be canceling that session. If you have any questions, feel free to go ahead and leave them in the chat in general, and we will be able to answer them as quickly as we possibly can. And yeah, go ahead and apply to the Morph Creator Program as well, as we are kicking that off. It's going to be a super, super cool event that we have going on there, and we cannot wait to bring to the table a ton of things from the Creator Program that you have never seen before. So go ahead and close out this session for now. Thank you so much once again to the Goldsky team for coming on. Thank you to the over 1,600 viewers that showed up in attendance today. You guys are amazing. We will see you very, very soon, and take care.